Welcome to Tales of the Resistance, a podcast about antimicrobial resistance. On today's show, we're joined by a rotating lineup of members of the I Am Responsible Project, a nationwide team of educators and researchers working on solutions to AMR. I'm Beth, one of the hosts, and we are joined today by Nafisa.
Hi, guys.
And our star guest today is one of the graduate students with our team, Andrew.
Hi everyone, my name is Andrew. I am a master's student in the Department of Biological Systems Engineering at UNL, and I am from Colombia originally, and I have also been part of the I Am Responsible initiative, thanks to being part of Dr. Amy Schmidt Lab. So I've been involved in different projects involving AMR and all that. I also have some experience with machine learning and AI because my main project involves these topics. So, yep, that's pretty much it.
Thank you for joining us, everyone. So today we are talking about machine learning and AI and how it can help in the fight against antimicrobial resistance. So I just used those two terms, AI and machine learning, in that brief description. Andrew, as our kind of expert on AI, would you do a brief explanation for those who don't know, kind of if there's a difference between AI and machine learning?
Thank you, Ed, for saying that I'm an expert, but I'm not an expert whatsoever. But I can tell you a brief definition of machine learning, AI, and even deep learning. So let's start with AI, artificial intelligence. So it's considered a branch of computer science that studies machine intelligence. This is like a broader concept that refers to machines or computers performing tasks that typically require human intelligence or even a level higher than that. This includes things like reasoning, learning, perception, problem solving, language understanding, and decision making. So let's think of AI as a broader dream of machines mimicking human intelligence, making decisions, recognizing speech, and other tasks that humans can do, and even these machines can make it even faster and better. It's a science fiction to reality, the umbrella under which all machines' smartness falls. Now, machine learning, ML. This is a subset of AI that focuses on the development of algorithms and statistical models that enable computers to perform tasks without explicit instructions, relying instead on patterns and inference. It is about machines' access to big conscious data and letting them learn from themselves. So let's think ML, machine learning, as the AI's pragmatic cousin. It is all about data and algorithms, teaching computers to learn from patterns by example. It is not about robots taking over, but about smart systems making our lives easier. Finally, we have deep learning, that is DL, which is a subset of machine learning, ML. It uses structures called neural networks to make sense of large, complex data sets. Is the tech behind the magic of voice assistants like Siri and self-driving cars like Teslas. So that's pretty much a brief introduction to these topics. And also I wanted to just tell you guys that AI and machine learning has been around more than we think. It has been a boom for the last 20 years, but AI has been around from the 1950s. So right now just is booming because of two main reasons. So the first one is because our computers, our systems are more powerful than ever. And the second reason is because we have more power to store the data. So we have the cloud, and the cloud let us to store being like big quantity of data. So that's why AI can produce better predictions right now. And that's why we are talking about AI much more than before.
I think that's interesting how I wouldn't have thought that that need for being able to store all the information is one of the reasons it's booming now. But because as you have machine learning, it has to have access to a big range of data in order to learn, essentially. Um,
That's right. The bigger the data, the better because you have more stuff to recognize patterns. So it's like I don't know when you try to learn about a topic, when you I don't know read just a book is not enough, but if you read a couple of books, it's getting better and better, and computers do that really well. So with
Mhm.
a lot of data, they can recognize patterns that um, we don't. So yeah, that's why AI is booming right now.
That is interesting. I've learned a lot about, much more about AI of recent. So for today, we're talking about AI and how it has to do, how it has the potential to help with AMR. So AI can be used to accelerate the process of antibiotic discovery. And this is so important because new antibiotic discovery can take, oh, an average of $1 billion and a decade of research to discover. And the reason that takes so long, that decade of research, is because the number of drug-like molecules that could potentially exist is roughly 10 to the 60. So that's 10 with 60 zeros behind it, which is a truly incomprehensible number. But AI can run predictions of new drugs much, much faster than a human can do in those laboratories. So the research paper that we are going to discuss today is a collaborative project between MIT and McMaster University in Canada came together to explore the use of AI in drug discovery. They eventually discovered a new antibiotic with the potential to fight a drug-resistant bacterium pathogen. But we should keep in mind that just discovering a potential drug compound is just the beginning of the long, long process of antibiotic discovery. The estimated timeline for AI-discovered antibiotics to become available for prescriptions and human consumption is 2030. So AI can vastly accelerate the process, but it is still the long process of antibiotic discovery.
Well, I would like to add that if you were using artificial intelligence in any sort of like drug development, it doesn't have to be only antibiotics.
Mhm.
Uh, there are, I think, less chance for errors when you are using it for like demonstrating it on some patients or something, or even when you are just sequencing the drug, if you're developing any uh gen genetically sorry biotech using biotechnology to developing a drug, there will be less chance for error when you are coding that drug. uh but if human were involved, only human were involved, then I think there will be more scope for errors that would like bring more um you know, that would need more time and also more financial investments. And I think using AI could cut down with time and financial investment as it will cause less error.
Mm. That's interesting point about it having less error potential. I wonder if that's because it's dealing with pretty straightforward data, because like a lot of times you'll hear about AI making mistakes all the time, like silly mistakes or kind of like alarming mistakes. It's still in the training process. I wonder if, Andrew, you have any insights.
Yeah, I have the potential to be more accurate, and especially if you develop a machine learning model or AI model that just focuses on one simple task. Let's say just drug discovery or antibiotic discovery, because we see some that is called hallucinations with bigger models like ChatGPT or other big AI models that are called generative AI because they do more than just one thing. They can give you an image, they can make poetry, they can do a lot of stuff. So there is more chance to have those hallucinations you have those bigger models that do a lot of other tasks. But if you have a model that just focuses on one simple task that is not simple, but you I think that you get my point. That is just
Mhm.
focusing in one thing. You will get really pretty good results. And with this one, especially 93% of reduction of the screening process is pretty good, but it's still not as good as one will, think. Because this data set was kind of small, like
Mhm.
7,000 molecules is not that big. For instance, if you are going to screen 1 million of molecules, you will still get to manually screen 70,000. So it's still a lot of molecules, but it's good that progress is being made in this field. So it's still a lot to come, but we have to start somewhere.
Any other thoughts about how AI could be used in the fight against antimicrobial resistance besides just antibiotic discovery?
I mean, there are a lot of different ways that we can use AI to combat and fight AMR. So one that came to my mind recently was to develop like an app or something that can use your daily information, like I don't know, the Apple Health information that you have in your phone and other parameters that you can enter in the app to to calculate the risk of an AMR infection. So it will be really good to have this kind of risk assessment app for users, for daily life users, to see what they can do, what they can improve, what they have to avoid in order to, not get, an AMR disease related. So that could be one way to use AI, use information, use your data to fight back AMR and prevent infection to happen.
This could be a really cool invention for like antibiotic use control. So the antibiotic resistance is basically a product of antibiotic abuse, overuse, or
Mhm.
underuse. So if this uh, software or like app or program could be developed, I think that this could be used in alarming people, or I mean letting people know that, oh, you were one dose away for your full course like medicine for,
Mhm.
yeah, so you should take one more. And then like calculating their symptoms or something, they would tell them that, "Oh, you are free from bacteria, so you don't need to like take another pill, so just don't take it." And the abuse of antibiotics in livestock is like, it's it just cannot be described in words.
But that is a good perspective, because in our countries there is like a misinformation everywhere about antibiotics. So like AI platform, AI app will help people make informed decisions about antibiotic usage. For instance, people in my country will use antibiotics just for a common cold. And of course, it didn't help and make the things worse because right now you're not just dealing with a cold, but also you could potentially increase your risk of antibiotic resistance bacteria. So that is another way that AI and machine learning could help people make more informed decisions every day.
Now, Nafisa, when you mentioned about how much antibiotics are being kind of being abused in the livestock sector, it really got me thinking about how AI could help, because some of the problem is that it's really hard to identify when a livestock, cattle, whatnot it is, pig, is sick. So a lot of times they will just give the whole herd the antibiotic because otherwise it's spread really quickly. But if they were able to use AI somehow to quickly and accurately identify the diseased animal, an animal that's coming down with something, and separate that from the herd, then they might not give so many just we have to give these antibiotics because, it's likely that they're going to get this, rather than likely they might be able to might be able to come to a place where they know this one has it and they can use the antibiotic rather than just it's likely we'll get this.
Great that you mentioned that it would be great to know that animals are sick before they are really sick. And actually, here at UNL, we have a group of people that are studying that. One of them is Dr. Ty Smith, the husband of Dr. Amy Smith, and he is working with a group of computer scientists to develop image analysis monitoring systems to identify pigs that are sick or that are becoming sick before they're getting really sick and get action before it's too late. So there are people that are working really hard to help with this. So we're in a good pace, but we have to keep going.
And also to like monitoring how much antibiotics are they using in treating those infections, because the tendency of people in agriculture or in livestock or anything that is like for business, they think that if we use like the nitrate problem in Nebraska, the farmers thought that if we use more nitrate in our soil, then the plant will grow more, so we will cultivate more crops and we will sell them in better price. But that caused like water pollution, soil pollution, and other health issues like cancer in infants and all other problems. So the same thing goes for cattle production and other livestock production with antibiotic introduction. So if one cattle is sick or one pig is sick in a farm, the farmers think that, I mean, I have worked with farmers who have the same type of mentality that one or two bird or one or two pig is sick in the flock, then they will basically give antibiotics to every other animal or bird in his farm or in that group where a bird got sick or a pig got sick. So those other like pigs or birds, they didn't need those antibiotics. So if we could come up with any diagnosis or screening ideas or equipments that are AI driven and that could like do not need any biochemical or any biotechnological tests to detect or microbiological tests to detect infection, as it's very time consuming to collect samples from the farm and then test it, and it takes like at least 24 hours to grow a bacteria and then try to understand doing like MIC and other biochemical tests to understand which antibiotic is going to work best for this infection treatment. So if we could really come up with some artificial intelligence that can tell us or help us diagnose this type of infection right at the spot, we could just separate that animal out of the flock and then just thoroughly screen all the other animals and see any other is infected or not, then just screen out those and just treat the infected ones, not the other ones. And also with the dose basis, if we also come up with some other cool artificial intelligence ideas or apps that could help us to identify the dose without doing any biochemical time consuming experiments, I think that would be very cool.
Yeah, the quicker we can identify the animal that is sick, the better. Can get them out of the herd, can get just that animal, the antibiotics instead of just the entire herd. It's making me think, rapid diagnostics, that could be something that AI in general could really help with on the human sector as well. Since a medical professional does not know what disease is affecting you, they don't know what it is, they'll give you as much of an estimate sometimes. It's not always, this is what you're actually sick with. Let me give you the exact right antibiotic. Sometimes it'll just be a broad spectrum antibiotic. They're more often used in those situations. A broad spectrum antibiotic is ones that will they're used on multiple, they can attack multiple bacterium and kill them. But the problem with using a lot of broad spectrum antibiotics is they're the ones that have the most antibiotic resistance built up against them. So we don't want to use those often. So if you had more rapid diagnostics, if you could figure out what exact antibiotic is actually needed, then you could go for those narrow spectrum antibiotics, and that could also do a lot to slow the spread of AMR.
That's right, Beth. I just found another paper that talks about this topic. So they say that normal diagnostic lasts 24 hours at least, and also requires a people like a person that is really an expert on the field and can perform the test really well. And they found that using ML, machine learning, and other techniques can reduce the time to 3 hours. So that could really help the diagnostics of people as well.
Yeah, that's a huge cut down in time.
One way that AI can help is record keeping. Let's say in my country, sometimes you get sick because of food, because it doesn't have the proper, processing. And I was watching a video yesterday of one of my favorite YouTubers, and he got listeriosis because of Listeria monocytogenes, and it's a pretty big, issue. And if we have the ability to keep a record, we can do recalls as you do here in the US, that you recall the food that was contaminated with that, bacteria. So AI will help like developing countries as mine to keep record and perform those tasks like, recalls and all that to avoid spreading more these harmful bacteria.
Yeah, so it can more rapidly target where, let's say, a infected lettuce, was all sent to what farm it came from.
Exactly.
Yeah. Yeah, so many ways. So many great ways that AI has the potential to help us. And I think that's a good note to end on. That we hopefully our listeners came away feeling educated on AI, and also maybe a little bit hopeful. I'm feeling a bit hopeful now that our own abilities to innovate and invent are able to help us in combating AMR. So thank you everyone for joining us.